turn off my camera. Testing, 1, 2, 3. Okay. Copy.
Hello, my good man.
Hello. Can you hear me?
I can hear you fine. Can you hear me?
Yes, I can. You're a little bit muffled. But
okay, I'll speak a bit louder.
Okay. Yeah. So you're ready for me to hit the button? I think. Yeah, it's 11:01. So I'm not using my camera. I'm in my creepy basement. Plus, it helps my bandwidth. So, do you mind that if I just I'm not I'm a disembodied voice. Oh, can you hear me? Mark, can you hear me? I think Mark dropped out by accident.
Charles, can you hear me okay?
Yeah, I can hear you fine.
Smashing. We'll go up there, yes.
Okay.
Good man.
All right. So, all right, I'm just typing a chat message. Do you ever open up the watch page and then turn on mute and then just so you can see the chat? Do you ever do that?
I don't know what you mean.
Oh, okay. So when there's a live hangout, it's being broadcast over YouTube, and so even though you're in the hangout, you could still go to the YouTube page. So they call that the watch page, and then there's usually a several second delay. So if you go to the watch page, you want to click on mute, or the silent.
I've not even got it open, so there's no conflict.
Okay. So I'm going to hit the on air button, and then we'll go live, and then so I'll just introduce you. Do you pronounce your last name Doxey?
They're very good. Yeah, that's it. Yeah.
Okay. So I'll just introduce you, and then we'll just get started. We'll just play it by ear. Okay.
Good man.
Right. So I'm going live now. Oops. I forget which button I'm supposed to push. Settings, bandwidth, camera on, mute microphone. Oh my goodness. It's been a while since I've done it. So I've got the button that says off air, and I got that button. All right, it'll take me a few seconds. Hold on a second.
Go for it.
Oh, right. The button says Well, this is very strange. Doo-doo-doo-doo. Video call. The thing is, when I set up this stream, there was this button that says, you know, automatically send data when you go live. Oh.
You were already live. I heard you talking.
Yeah, well, you know, okay. So Hillel Finder says I'm already live. Okay, so for some strange reason, it says off the air. Okay, so I think we're live. So,
can somebody confirm that again?
Yeah. So Hillel Finder says that we're live. Okay, so I guess what the problem is that when I set up the stream, there was a button that said, click this button, or, you know, it says automatically, you know, go live when you start the stream. And so I was like, well, I don't really sure what this is, and I clicked it. So I guess what that meant is as soon as I started this Hangout, I started broadcasting. Okay, so good thing I wasn't saying really, really bad things about everybody else in the Hangout. Anyway, so my name is Charles Breeling, otherwise known as Flat Earth Math. Here is Mark Doxey. We're just going to have a civil conversation, and we're going to just talk about whatever's on our mind, and we're going to avoid talk about personalities. There's a really great phrase, and it's you know, small men talk about people, average men talk about events, but great men talk about ideas. So hopefully we will focus on the ideas. All right, Mark, what's on your mind?
Good. Thank you for giving me your time. I'm curious as to why you call yourself Flat Earth Math.
Well, partially, and this is going to be used against me. Partially, I wanted to attract the attention of Flat Earth people. I wanted to have a screen name that didn't say, you know, I'm a glober, because then most Flat Earthers, they won't even pay you a second glance. So I wanted to have a screen name that would attract the attention of Flat Earthers. But then I picked my avatar as a globe so that they can kind of, like, if they wanted to put together the clues, they'd figure it out. Because the purpose of my channel initially was to not present anything that said that I was a glober. The purpose of my channel was just to have experiments that people could do using simple equipment in their own backyards to come up with their own conclusions. You know, like I really, when I made the channel, I wanted to be 100% agnostic. I didn't want anything to give it away. And I think for the most part, most of my videos do that. Although in the comments, like at some point in the comments, I was just like, yeah, I have to tell people the truth, you know? So when I engage people in the comments, you know, I'm a glober, right? But the videos, and in fact, Mark, you might think this is funny. My most recent video was an entry for Wolfie's Equinox Challenge. And I had commenters saying, great job on the video, who were Flat Earthers who didn't know I was a glober. So it's like they could watch my video and not know which side of the fence I was on. And that's, you know, that's just gold.
Yes. Globers over the past sort of 3 years maybe, have shifted their position. You haven't, so why do you bother?
I'm sorry. Say that again. You said you shifted position?
No. Over the past sort of 5 years, for me, it was 3 years ago. People who believed that we lived on a globe has shifted their position to being flat.
Oh, I don't know of anybody. I don't know of anybody who's looked at it seriously. In my experience, it's only people who, quote unquote, know it's a globe because of their schooling. Right? If the only reason why you know it's a globe is because everybody's raised with the globe, then yes, you're open to the flat Earth message. But if you've spent any time studying it as a glober, or you know, I mean, like, that's my position. You know, like I was taught the globe just like everybody else, but then it wasn't until I got engaged in the debate that I started really studying it. And once I started studying it, it was like, all right, so there's just no question. Does that make sense?
No, I think you missed my question. Why do you bother? You've always believed it's a globe. You've investigated its globe. So why do you bother with these nutcases that think it's flat?
Okay, well, first off, I think the nutcases are few and far between. I think most people who are on the flat earth side are very reasonable people. They're genuinely interested in searching for the truth. But I believe in spreading the truth. I believe that, very, very strongly, that if somebody is if somebody is operating under a falsehood, or and they don't know it's false, right? Then no good can come of that. I mean, it's one thing to play make believe, but if you're not playing make believe, if you genuinely think something is true and that thing is false, I don't think any good can come of that. So what I try to do, the reason why I'm in the debate, is to try to encourage people to learn the truth in as gentle
Yeah.
a manner and as polite a manner as possible. If that makes sense.
No, you've certainly done that. My very first video I put up, and it was only in the last sort of 6 months I put it up. It was entitled "The Earth is Observably Flat." After I had investigated the subject for about 3 years, and you get people responding with, "Yeah, thumbs up, great, we love it, we agree with it," and then others become quite nasty and hostile, and then there's people like yourself who write a whole essay analyzing the video and in a very polite way putting the alternative view and maybe showing me the error of where I am.
Yeah, I mean, the thing is, what I really liked about your video and the rest of your videos is that you have a very thoughtful approach, a very measured approach. But in that approach, you might make an honest mistake. Okay. And so what I tried in my responses to you was to say, hey, I thought you did a great job on this video, but like, can you take a look at this, in a little different way?
Yeah.
And then that's what I've just tried to, encourage people. But it is a shame that there is so much nastiness, and the Globe folks, they're some of the top Globe channels are the people who are in it, purely for sport. It's like shooting fish in a barrel. That who could be more profane, who could use the most colorful insults, and that's very entertaining to some people.
Yeah.
I just choose not to go that route.
Yeah, well, I appreciate that, and you're quite right. Actually, on both sides, they can be quite hostile, but it's more from the Globe side that it's a bit of sport and mocking.
Right. Yeah.
So
I don't think anything good can come of that. I mean, it's fine for it to be an entertainment medium, but the thing is, I'm not in the debate for entertainment. So I don't, I mean, I like to produce videos that are entertaining while being informative. I try to throw in a little bit of humor, a little bit of, silliness, but I want people to walk away, having known something or learned something that they didn't know before.
So, are there any absolutes in life?
Well, there are absolute truths. The question, I think, is whether mankind can learn those truths. For example, I think objective reality is absolutely objective, right? It is what it is. But you could have 10 observers to some, crime, say 10 eyewitnesses to a crime, and all 10 witnesses will tell a slightly different story. And the stories that they tell, they will be their truths, the truth that they hold in their heart, and then the more often you tell the story, like, oh, I heard 3 shots, well, the more people you tell, I heard 3 shots. I mean, it will be a permanently embedded in your head, even though the other witness says, I heard 4 shots, and now 4 shots is his objective truth, but if there was a video camera, the video camera would have recorded exactly how many shots there were, so.
Yeah. Okay, so in a crime scene, we could get to the absolute truth. But when it comes to theology or cosmology or religion, sorry, I mentioned theology, or politics, people get so impassioned by their opinion is the correct one. And this sort of that cognitive dissonance sets in, and then we're looking for confirmation bias that suits our position. and we're so emotionally involved with our opinion that we're not prepared to listen to or acknowledge that we might be wrong.
Right, right. Well, the one truism is that facts trump, I'm sorry, emotions trump facts, you know? And so in a debate, or if there's something where, there is an objective truth, but there's people on opposite sides of the fence, each arguing that their side is right. Well, who's going to win? The emotion's going to win. Okay. And like, for example, here in the United States, you might have heard of this character called Donald Trump. I think he might have made the news over on your side. So duly elected president 2 years ago. And, what was interesting is that there is this phenomenon called Trump derangement syndrome. So it's like just the mere fact that Donald Trump is in office, people are literally going insane. And so it's like, yes, they're running on 100% emotion, but what are the objective facts? Unemployment is lowest in 50 years. The economy is raging. I just got I've got a little retirement account that I set up a bunch of years ago. And so I was looking at the numbers, and, the 1 year return on the funds in my retirement account gone up 17% in 1 year. It's like, so those are actually objective facts, but, oh, well, Trump is Hitler, so I'm going to just lose my mind,
And does that translate into the debate that we're in at the moment on either flat or globe?
It does. If the thing is, I feel that the folks on the flat earth side genuinely believe, like they genuinely believe the earth is flat. And then if you genuinely believe the earth is flat, you have to, like, there's no choice. You have to believe that you've been lied to deliberately your whole life. And that's a very... go ahead.
I taught my son the heliocentric model. I lived in Armagh, and it's a very world famous observatory in Armagh in Northern Ireland.
Okay.
I would go there regularly. I loved it, totally absorbed with it. And I taught my son the heliocentric model, not because I wanted to mislead him, but because I was taught it, and I was taken in by the sort of the hands-on.
Okay. So more like a Santa Claus story. Like you raise a child a certain way, and then like the kid's not going to believe in Santa Claus as an adult. Yeah, I get that.
Yeah. That's not my position. Some people do say that we've been lied to and that they're into this conspiracy. No, I'm a bit more laid back about that. It's something that we've inherited. If what was the name? I forgot his name. The guy that first of all proposed the heliocentric model, Copernicus.
Yeah, I think Copernicus was one of the first ones. I really need to learn the actual history, but the thing is, it's gone back and forth a bunch of times, and there was something where the mainstream model was what they called geocentric, which actually geocentric was a globe Earth at the center of the solar system. A lot of people don't realize that. And then somebody was saying, well, I think the sun's at the center, but maybe they were at the fringe, and then it kind of flopped, and then sometimes religion got involved, and so it's gone back and forth a little bit, but it's always been around a globe. Like nobody in the last, say, 3,000 years actually has believed the earth is flat. I mean, no mainstream, nobody who's studied the sky has said that. It's always been a question of, is the globe Earth at the center of the solar system, or is the globe Earth orbiting the sun? That's always been the question in the last, recorded history.
Is that your opinion, or can you support that?
Well, no. I mean, if you take a look at the actual people who wrote stuff down, I don't know if you can find any writings by any astronomer, like let's say it's the court astronomer of King Leopold or whatever. It's really hard to find writings that say flat Earth.
So where did the joke of falling off the edge come from then?
Oh, well, I mean, the thing is, there's folklore, but like even in Columbus's time, it was just unknown. Like what was west of the Atlantic Ocean? It was kind of unknown, but there was a globe like on somebody's desk, because like they knew it wrapped around. I mean, they knew eventually you'd get around to to Asia, but they had the distances off, and there was an issue of like one astronomer had some very, very detailed notes, but then they translated it from like Persian, and then they got the distances wrong, so that they ended up with like a model globe that was like off by a factor of 2. And so Columbus was like, well, if I just go eastward from Portugal, I'm sorry, westward from Portugal, I'll get to India, So
Well, I remember when I was a kid and listening to those stories and wondering in the timeline of it that Columbus went west before Newton and Cavendish. And so what convinced him that he was going to actually stick to this globe if gravity hadn't been established yet? Well, just one moment, please. Sure. I've got a very noisy household. Can you hear Thomas's, my son's computer in the background?
We could hear some noise in the background, but it's not too
okay.
distracting.
Okay, it's easier to leave him.
Okay. How old is your boy?
He's 7.
Okay.
No, his mom promised me we'd keep him out of the room, but he's in the room.
Right. Well, that's because you're in the room.
Yeah.
So
if that's not distraction, that's fine. That's fine.
Yeah.
That's what I wondered. Gravity came after Columbus went west.
Well, no. The thing about gravity is that everybody knows that like if you drop something, it falls in a downward direction. So like that's what we could call gravity, right? And so everybody, prehistory, I mean, you drop a stone, it lands on your toe. I mean, that's whether you call it gravity or whether your name is Isaac Newton or not. I mean, everybody knows that that's a fact. So there's no question of like, oh, well, if I sail across the ocean, will this force that is always, caused things to fall in a downward direction? Like there's no question that was true. My understanding about Newton, and I could be wrong, is that he was the first, and people in the chat are going to correct me. He was the first to connect what we see in the sky, the orbits of like the moons of Jupiter, say. Well, what keeps the moons around Jupiter? Well, there's this unknown force, right? Well, what keeps the apple falling to the ground? We call that gravity, or we call that the downward force, but I'm sure they called it gravity long before. But my understanding is that Newton was the first person to connect what you see in space with the moons of Jupiter with the apple falling to the ground. So like it's the same gravitational force. That's my understanding.
So he sort of brought together the obvious in a sort of mathematical. It was the obvious that. So you're saying that what goes up comes down whenever you are on.
Now that's the obvious part. What goes up comes down. That's the obvious part. What was not obvious is witnessing astronomical features and connecting that to falling an apple. Like that was revolutionary. That was absolutely revolutionary. Like who's to say that I'm looking up at the moons of Jupiter and that's the same force that causes an apple to fall? That was completely revolutionary. All right, so that's.
We'll move on from that.
Okay.
Just one thing I'd like to let the audience think about is where did the joke come from of falling off the edge? If everybody was sort of confident we're on a globe and you don't fall off it, where did the joke come from?
I don't know. I don't know. I think it's like the thing is people have believed in dragons. Somebody has said that in China there was this great dinosaur dig, and then so they found these skeletons of these huge beasts. But it's like, what are they? Well, they're dragons. And we later found out that they're dinosaurs. But it's like, so where does this stuff come from? I'm sure folklore gets passed down, through the generations. But I don't think anybody, nobody who took 12 seconds to think about it. If you go over the edge, like if you sail westward, and you go over the edge. Well, then how come the oceans aren't emptied of water? Like it doesn't rain all that much, How come the oceans aren't just drained of water in a second,
You don't live in Ireland.
Okay. Right.
Okay.
Okay.
Okay. Well, and we've handled that, and we'll let the audience sort of digest that. I asked you about your name, Flat Earth Math. So
Yes.
why did you attach math to your
Oh,
Flat Earth?
well, I mean, I didn't want it just to be like, Joe Flat Earth. My focus, my interest is in the math and science.
Yeah.
And there is a great deal of math and science. And then so, if you look at my channel description has never changed since day one. And it's focused on the math and science of the flat Earth debate. And so I can now justify my name, Flat Earth Math. I'm focused on the math and science of the flat Earth debate because, in my view, there is no globe Earth debate. Like people aren't, debating, like the globe is mainstream. So flat Earth is this, idea, this alternative idea.
Yeah.
So it's the flat Earth debate. So I can justify my name, but at the same time, I also get people to my channel. You may use the word clickbait, but I get people to my channel who don't know that I'm a glober, who look at my videos and are like, that looks interesting, and so it's like I don't want them to be shunned, because they think I'm a glober, like they wouldn't even click on my channel.
Yeah. I noticed that subtlety actually, not as a criticism, but I did notice that you were presenting yourself as neutral.
Yes.
And enticing people to investigate a bit further. Now, from the flat Earth point of view, what's put forward is that maths is a language and not necessarily reality. I'll give you an example. I help my daughter with her maths homework, and she'll have a question like, Sally has $5, she spends 60% of it on candy, how much does she have left? For the sake of the question, Sally is a fiction, and so therefore she doesn't really have. Nobody has the $5. It's
right.
just a mathematical question. Do you understand where I'm going with this?
Yes.
Okay. So, do you have any comment on that?
Well, you could have the question: Sally has $6 and she spends, $7 on candy. How much does she have left? Like it's...
Yes. Yeah. She has problems with the bank.
Right.
Oh, here we go. No, another child. Oh dear. We'll just carry on. If it's not a distraction, we'll carry on. So when it comes to geometry describing the globe, the same description could be of a golf ball. Now, the golf ball is real. We know it. We can hold it. But because we can apply the same geometry to the globe, does it make the globe real?
No, it does not make the globe real. Because you could apply the same geometry to, say something that you model in a 3D, 3D software, rendering software, Blender or something. And so you could say, well, I just modeled it. It's a globe. I modeled it, but it doesn't make it real. Okay. The geometry is the same, right? You could measure the angles. You could place a virtual camera so many, units away from it. You could say, well, what will this camera see? You can zoom in. You could do all sorts of analyses. Those analyses don't make it real, okay? But those analyses are very helpful because if somebody is like a glober and they're like, well, how big should the moon appear in the sky? Well, it's really easy. What's the diameter of the moon? What's the distance to the moon? Let's model it, and you could figure out very, very quickly that, well, if the moon is the size and the distance that, the authorities say it is, well, then it should appear about half a degree in the sky. But that mathematical analysis doesn't make it real. It confirms what we see, but it doesn't make it real. And that's, I think a lot of flat earthers put the cart before the horse because they think, and I've heard them say this so many times, like the math doesn't prove reality.
Yes.
I would say math is a great tool, right? Math is a great tool, but math doesn't prove reality.
Okay, so do you have a flaw in your position with that then? You call yourself flat Earth math, but you're saying that math doesn't prove anything.
Oh, I don't think there's any scientific proof of anything.
Oh, good.
I mean, and I've said this, like, I don't know, I need to make a video that says proof does not exist. The great quote is, proof only exists.
Excuse me, I'm gonna have to stop that.
So
go ahead.
Okay. So there's a great quote that says, proof only exists with alcohol. Oops. All right. So proof only exists. I'm sorry. I was watching the watch page and it looked like you were taking your headphones off. All right. Proof only exists with alcohol and math. Okay. And that's a very true statement, because in the scientific world, you will pretty much almost never find a scientist saying that there's proof. There's scientific proof. There's scientific evidence, and then there's theories that are backed by evidence, and then you can have a mountain of evidence. Like, for example, DNA. No one's ever taken a picture of DNA, an optical picture, and no one ever will, because it's impossible. You cannot take an optical picture of DNA. Well, how do we know DNA exists? Well, there's a mountain of evidence, So I don't know. I guess I kind of ran off the rails there, but yeah, proof doesn't exist.
I get what you're saying. There is a weakness in your position when you say that.
Well, if I say proof it doesn't exist, then I say then the proof of the globe Earth doesn't exist, right?
Yes. Okay.
Was that what you were going to go for?
I'm not going for anything.
Okay.
I'm trying to be polite, but that's where I am in that. My conclusions that I draw, and I am open to new ideas and to correction. And you've almost confirmed that, well, because you describe something with math doesn't make it actual. And yet when I ask people, well, no, show me your globe, they resort to maths.
Okay. Well, the trouble is scale. Like, say, show me a globe. Okay, well, you're standing on one. Well, the view from 6 feet above the Earth is not a great view. I mean, it's beautiful. We live in a beautiful place, but you don't appreciate that we stand on a globe from 6 feet above it. Okay, so when people say show you a globe, well, there's a couple things I could do. I could send you up in a rocket, and put you in orbit, and well, that's not really practical, So what do people have to resort to? I mean, they can't put you on a rocket. They can't just tell you to look down, because it doesn't look like a globe when you look down. So what else is there? Well, now we could start talking about modeling, and you could have a desktop globe and you could shine a flashlight on it. You could do all sorts of things, but you can't. The reality of it is, since you can't go into space, how am I gonna show you the globe? I can only show you the globe by some sort of analysis. But what I would say is that if you can take detailed observations, and if you discover that those detailed observations are correlated with the globe model, now again, it doesn't prove the globe model, but if your detailed observations correlate with the globe model, then that kind of indicates that maybe the globe is the truth, and if these same detailed observations are absolutely not correlated with the flat Earth model, so it's like, well, okay, so the globe is sort of winning points and the flat Earth is losing points. And then there's, certain slam dunk things, like, for example, putting rockets into space, putting satellites into space. Like, literally that doesn't exist on the flat Earth. So if you believe that, any of the space program is real, then the Earth can't be flat, So that's where I was talking about with the conspiracy thing.
Certainly plenty of years left in this debate. Just by what you're saying, that there's no absolutes. I asked the question, are there any absolutes?
Oh, well, yes, there are absolutes, but there's no proof. I'm sorry, I interrupted. Go ahead.
No, I think you see my point, and hopefully the audience can see the point as well.
Yeah, and there's a nice comment from Soundly in the chat. The thing is, when people say there is no proof, flat earthers seize upon that, saying there's no proof of the globe, right? Which means that, oh, it's a coin toss. Flip a coin. The Earth could be a globe. It could be flat. So flat Earth math is saying, oh, well, there's just no proof. And so Soundly has a very good point. But it's scientific proof is what I'm talking about.
I agree with Soundly. From the opposite point of view as well. It's just, what did he actually say? What was his quote again?
Well, all right. So he said, I disagree with those sentiments, flat Earth math. There is deductive proof, math, and there is inductive proof. They are different in nature, but saying there is not proof is misleading to flat earthers. And then he further says, what we can prove deductively in the scientific method is that our hypotheses validate or invalidate our model. And so that last sentence, I would just take out the word prove, because if you say your hypothesis is validated, or your hypothesis is invalidated, or the model is validated or invalidated, yes, I agree with you completely, but it doesn't prove that it's true. And the crazy thought is that we're living in the Matrix. It's like with all the technology in the world, there is no way of proving conclusively that we are not living in a simulation. Okay? Because the simulation could be run by, supercomputers that are, simulating everything we see with our eyes. Everything we see with our scientific instruments, it's all simulation. There's no way of disproving that, so.
Charles, we're halfway through. I've asked all the questions. Do you want to ask me a question?
Yeah. So I'm just curious, is there anything that, like, for example, you were raised with the globe, and then you said you did about 3 years of research. And then you kind of, my understanding is that you've sort of concluded that the Earth is flat. Is there anything that tipped you over the edge, or is there any body of evidence that you think is the strongest in terms of a flat Earth?
I have 4 go-tos that tip me over the edge. The first is it's visibly flat. Now I know Soundly will contradict that with his pictures of the Pontchartrain Bridge. I live in Ireland. We have quite a moderate climate, quite a consistent temperature throughout the year, and I see things across a 35-mile stretch at the Isle of Man that's not consistent with either his pictures of the Pontchartrain or with the globe Earth model. I'm seeing things that I shouldn't see.
Okay.
So that was one. Number 2 is I don't sense any movement. Number 3 is the aircraft going from New York to London, or London to New York. It's the same time.
Okay.
And my fourth one would be the X, Y, Z or Z axis. Because, well, first of all, we have to, the X axis is the horizon, the Y axis is the up and down, and the Z axis is from my feet outwards from where I'm standing. If in Soundly's pictures of the Pontchartrain Bridge, it's curved on the Z axis, then I should be able to shift myself and see the same curve on an X axis if I change my position, and I don't get that.
Okay.
So there's my four things that I depend on. A lot of the other stuff that the flat earthers depend on are nonsense, and I try. If they look stupid, I look stupid. So that's my 4 ones I'm sticking to.
Okay. Can I jump in? I just started taking notes very late. Remind me again the first one. Oh, it's observably flat, right?
Yes.
Okay. So do you mind if I just say a few words about each of those 4? I mean, again, this is not a debate show, but this is a conversation, and I'm not going to try to convince you, but do you know, because I do respect the civil conversation, and I don't want to try to make it sound like I'm trying to go over the top on you. But first off, I would agree with you that the Earth is observably flat. There's this video that I've got going around in the back of my mind. At some point, I'm going to make it. I'm going to say, what is the obvious shape of the Earth? And I'm going to lead with the obvious shape of the Earth is flat, because the Earth is observably flat. Okay, I agree with you 100%. But if you look a little closer, like you talked about Soundly's pictures on Pontchartrain, if you take every single one of Soundly's pictures and you were to use Photoshop and the clone tool, and how I don't know if you've ever used Photoshop, but basically digitally erase the bridge or digitally erase the power lines, right? So you clone the water next to the bridge, and then you paint over the bridge. Okay, so in other words, you're taking Soundly's exact photos, but you're just making the bridge disappear and you're making the power lines disappear. What you will see is what you see in Ireland. You will see a flat horizon. You will see water that looks flat. You'll be overwhelmed by flatness. Okay, so what the interesting thing is happening in those images, and I don't know of any other place in the world where there's a man-made structure over water that goes for 20 miles. And Soundly has multiple examples of that. There's the Atchafalaya Basin. I don't know what they call that. it looks like a canal, but it's like a sort of a, piece of water that's 6 miles in length. And now that's only 6 miles. But then there's the Pontchartrain Bridge, which is 20 some miles. And then there's the power lines, which are like 18 some miles. So there's multiple instances of a man-made structure in a ruler straight path over water. And you don't get that in Ireland. I don't get that near Philadelphia. And people nowhere else in the world that I know of. So we see something there that isn't really visible elsewhere. But the water is just as flat looking. Does that make sense?
Okay, so you're separating with the sort of the temperatures and weather patterns of where sound lives to where I live.
Yeah, well, the thing is, there are conditions that make things, easier to see versus worse. There are also conditions that will cause you to see a little bit further, depending on like the temperature inversions. But I would always say, I would caution people to take a look at the numbers. So if you say, I can see the Isle of Man from XYZ, and according to the globe math, I shouldn't. Okay, I get you. But let's look at the numbers. How much is it deviating from the model? And I would say it's less than half a degree. All right. So it's like if you're looking at this thing on the far horizon, and and I would say that you're seeing less than half a degree further than you should, because that's because we have an atmosphere, and a lot of people they don't pay attention to how much difference there is. Does that make sense?
Well, my comeback to that is, if I position myself to Pontchartrain Bridge so that it was on an x-axis, would I see the same curve?
Yes. It's just it's not noticeable. It's curving the same in all directions, right? Like the water, the water of Pontchartrain is curving the same in all directions, along both the the x-axis and the z-axis. It's just that when you zoom in, like, the Soundly's best photos have been, I think he was shooting with a P900 at the time, where what can you see left to right? Well, you can measure it in feet, how much you can see left to right in that image. What can you see front to back? 20 miles. All right. So if we're taking a 20-mile long stretch and then something that's, maybe 100, 200, 300 feet wide, you're not even looking at the x-axis. It's all z-axis. It's like 100% z, and it's like this teeny little portion of the x. And so you're not going to see the curvature on the x-axis. Does that make sense? Because you're looking at it end on, like a pool cue.
But I've shifted my position now so that I can see the far right and the far left, and it's running along an x-axis. That's the bridge. If that's possible, if the land lets me do that.
Yeah, well, it's a lot tougher to see 20 miles of the bridge from the side. Now, the thing is, he has gone out in a boat. He has gone out on a lake, and it's tough because, like, you have to pan left to right. But, you could see, obviously, that when you're at the far left, the bridge is further away. When you're at the far right, the bridge is further away. But you can actually see the arc. It's not an ideal seeing conditions, because
on an x-axis you can see the arc.
Well, but it's only through panning, though, because you can't just capture 20 miles of bridge. You can't just see 20 miles of bridge from the side. It's extremely difficult to do that. Okay. I mean, like, you'd have to be in like a drone or an aircraft or something. But he has shot from the lake. But he pans the camera, and then you can actually take the images and just sort of stack them up. And yeah, it's very, very hard to see curvature on the x-axis. Extremely hard to see.
Unless it's not there, and when you see curve on the z, it's just because of the environment.
Well, but it's always matching what the model says. Like, I don't know. Are you familiar with Walter Bislin? The name Walter Bislin? Because what Walter Bislin has done is he's taken the measurements of the power lines on Pontchartrain, the causeway on Pontchartrain, including the marine spans, where the bridge humps up, so boats can pass. And he's modeled it using, software, 3D software, And then he says, okay, well, let's put it on a flat Earth, and then let's put it on a globe Earth. And what Soundly has photographed matches what the computer model says it should look like if the Earth were a globe. So I totally get that flat earthers say that the Pontchartrain imagery is an illusion. I totally get that. It's an optical illusion, but it's an optical illusion that matches the globe model. All right. So at some point, I'm not saying it's proof. I'm not saying it's slam dunk proof. I'm just saying it's kind of a coincidence that this optical illusion matches the globe.
Let's just conclude with what you just said there. That some of us will look at the Pontchartrain Bridge and say it fits. Others will say, or others will cry optical illusion. And we're just going to have to leave it at that.
Yeah.
Okay. Listen, I'm not dismissing Soundly. The only times I ever hear Soundly is from a Nathan Oakley flavor. I've never met or spoke to the guy, so we'll just leave it at that.
Yeah. Okay.
I'm sure I'd enjoy having a glass of whiskey with him.
Can I get on
another
to
question?
Oh, yeah. Can I get on to your point number 2?
Yeah, that was. I don't sense any movement. Yeah,
don't sense any movement. Okay, and again, I would agree with you. I don't sense any movement either. There's some great things like playing a game of I don't know if you have it over in the UK, Jenga, where you stack these wooden blocks up and you make a tower of wooden blocks, and then you have to pull out wooden blocks from the bottom of the tower, and it's like if the Earth were hurtling through space, spiraling on this crazy dizzying motion, you couldn't play Jenga. Okay, so
okay, well, that's not my analogy, but go ahead, carry on.
Anyway, so I agree with you. We can't feel the motion, but if you take a look at the scale of the Earth, and just run it through standard physics, like there's standard physics equations for centrifugal force, for acceleration, for momentum, for all these things, and then you ask yourself, okay, so what should the forces be? Like if and just on paper, like if you just were to hand a physics student these parameters, they're like, okay, I'm so many miles from the rotational axis of the Earth. I'm moving, like for example.
One moment, please.
Sure.
Lucille, what are you doing, darling? I'm just going to have to just handle the chat. Hang on.
Kids are great. I love them. My kids are quite crazy. Imrick's in the chat.
Right, Charles, I'm back again.
Okay, so and what was okay? So what I'm saying is, on paper, if you hand a physics student these parameters, you say, I've got a radius, I've got a tangential speed, or what they used to call edge velocity, right? So here in Philadelphia, we're supposed to be doing 800 miles an hour around the Earth's axis. So you plug in 800 miles. Well, then you also plug in so many thousand miles for the distance between Philadelphia and the Earth's axis, right? And then just run the numbers. You say, well, what kind of centrifugal force should I feel, or what kind of motion should I feel? And it turns out it's less than 1/3%, right? It's less than 1/3%. On the equator, where you're furthest from, you're moving the fastest, it is about 1/3%. And then so you ask yourself, well, could I feel 1/3% difference? And the answer is no. You can't. Like human perception. Like, for example, if you go and you drink a glass of water, do you then say, wow, I feel heavier? It's like, well, technically you're 16 ounces heavier, right? But you don't walk around saying, gee, I can, my shoes, my feet, I feel heavier because I just drank that glass of water, and that's what we're talking about here. It's very, very small. So you can't, feel it.
Because it's so big, you're not going to feel it.
But really okay, but can I stop you right there? That's what people say. Because it's so big, you can't feel it. And I would say, run the numbers. It's not that it's just, oh, well, I'm just throwing out your evidence because I'm just going to say, well, the Earth is so big. No, run the actual numbers, the actual factual numbers, and use the physics equations, and you will determine the magnitude. That's one of the biggest things in the flat Earth debate. Flat Earthers do not do not appreciate magnitude. They do not appreciate the value of things. You mean the numerical values. All right. I'm sorry. I interrupted. Go ahead.
No. I hear what you're saying. It comes from a presupposition, though, that the Earth is actually this size, and you can feel it.
Yeah.
You're not shaking my faith on it. I hear what you're saying.
Oh, right. So all I'm saying is that it is consistent. So let's run two scenarios. One scenario is that the Earth is flat and motionless. Or, another scenario is that the Earth is a globe and also motionless. I mean, there are a bunch of geocentrists out there who still think that the Earth, the globe Earth is the center of the universe and is not moving. Yeah. And then let's have the other model, the heliocentric model. The Earth is, turning on its axis. It's orbiting the sun. All right. So if you run the numbers, it turns out that we should not feel any motion in all three of those cases. So it clearly does not. It doesn't prove that the Earth isn't flat, or it doesn't prove that the Earth is a globe. Right? Because we shouldn't feel the motion. So all I'm trying to say is the fact that we can't feel motion does not discredit the globe model, right? It does not discredit the existing globe model with the size of the globe, with the speed of the globe, with the rate of rotation. The fact that we can't feel motion is consistent with the globe model. It also is consistent with a flat and stationary Earth. Okay, so it doesn't, it's a piece of evidence that doesn't go either way. But what people say is, I can't feel motion, therefore we're not moving, which is incorrect.
Oh, you had to put that a little bit on the end of it because it's incorrect.
Well, but what I'm saying is it's an incorrect conclusion, right? If I have a piece of information, a piece of data that says I don't feel motion, well, that matches all three of those models. It matches the existing globe model, it matches the geocentric model, and it matches the flat Earth model. So for somebody to say I don't feel motion, therefore it's one of those three, that's what I'm saying is incorrect. I wasn't saying that it was incorrect because the Earth is a globe.
You can't dismiss the other two.
Right. You cannot dismiss the other two by saying I can't feel motion. Can we go to point 3?
Absolutely, yeah.
Aircraft traveling east and west takes the same time. So the thing is, the Earth's atmosphere is part of our Earth. Okay, the Earth's atmosphere travels with the Earth is the easiest way of saying it. So, for example, here I am in Philadelphia. You're a bit north. Maybe you're doing 700 miles an hour around the axis. I'm doing 800 miles an hour around the axis. Well, the air that is outside my house is also doing 800 miles an hour around the axis. Okay, so the Earth's atmosphere is part of our globe system. I mean, it's part of our Earth. Okay, it's not that the Earth is turning a certain rate and the atmosphere is stationary. The atmosphere moves with the Earth, and so if a plane is traveling in that atmosphere and it goes eastbound, and then another plane is traveling westbound through the same atmosphere, they should take the same amount of time because the atmosphere moves with the Earth.
You're satisfied with that answer, and I'm satisfied that the idea that the atmosphere is sticking to the Earth and it's perpendicular all the way up to 20 miles. No, I think I find that incredulous. Now, I know you can throw back, well, that's a false, as a fallacy, because you find it difficult to believe doesn't mean it isn't true. There's no drag, is there? If you've got 20 miles of atmosphere all going at the same rate, then the stuff higher up has to be traveling so much faster than the stuff lower down.
Well, but it's not traveling so much faster. If you go 20 miles up, that's compared to the circumference of the Earth. That's not so much faster. That's a fraction of a percent faster.
It's so big.
Well, no. I'm not gonna rely on the so big. I'm just gonna say the heliocentric model with all of its measurements. Let's compare it to that. And so the 20 miles up, the 20 mile up atmosphere is not traveling a huge amount faster than the atmosphere at the ground level. It's traveling a slightly faster because it's a bigger radius. But 20 miles increase on the radius if the radius is 2,000 miles.
That's your maths coming into it, though, isn't it?
Well, no, I'm saying math is a tool. I'm just using math as a tool, not as proof.
You said that with confidence that it's going faster because of the maths.
Well, no. Okay, so let's forget the Earth and just talk about a hypothetical sphere, right? If you had a hypothetical sphere that is 2,000 miles in radius, and then you measured a point, the speed of a point on that sphere, like let's say it's on the equator of that sphere, and then you measured a point that is 20 miles in altitude above the equator, and just running the numbers, like forget the Earth, just this hypothetical sphere, and just measure the speeds of those. The speed of the 20-mile high, particle is going to be just a fraction of a percent faster than the ground level. Does that make sense? Just running the numbers.
I know exactly what your reply would be to that. I just don't buy it.
Yeah. Okay. Fair enough. Fair enough. You want to jump over to your? Well, I guess we did talk about the your number 4, which was the XYZ a little bit.
Yes. I've never seen curvature over an x-axis.
Yes, I agree. And the not from the ground. But what do you think about the balloon footage? Like when people send up high altitude balloons, and we're including flat earthers in this, when people send up amateur rockets, which go even higher, what do you think of the x-axis curvature that is visible in these imagery?
I can't draw any conclusive. I can't conclude anything from that, because those that send up these rockets or balloons already have something to prove, and there's a manipulation.
So, but what do you say when a flat earther sends up a balloon? Yeah, and returns these images, and the images show the same curvature, at 100,000 feet, as when a globe earther sends up a balloon,
I would need to see what you're referring to, but if it was a massive dinner plate that was so big, if you were to
the curvature would be the edge of the dinner plate, right?
It doesn't prove anything. Whether it's a globe, whether it's a plate, it doesn't prove anything.
So what if you were too far away from the edge of the plate to see the edge, and then you still send up this balloon, and it still sees curvature?
No, it doesn't. It might be seeing the edge of a plate.
Right. Okay.
It might be, but that's not my position. My position is that here on planet Earth, I don't observe any curve on the x-axis, and the highest I've ever been is on a jumbo jet flying to China.
Yeah. It's tough. It's tough. Commercial flights. The thing is, there's a lot of factors that are. I mean, some people say they can see curvature from a commercial jet, but the windows are just not really designed. You've got the real thick bulkhead, and you got a very small window. It's just not ideal conditions to see. But there were some really interesting stories from the folks who rode in the Concorde. And they said, you could see the curvature of the Earth. And and I've heard stories of people who rode the Concorde, and they said, well, they couldn't see the curvature. Well, the Concorde windows are even smaller than the windows of a say a 747. But what I heard a very interesting thing. It says the way you saw the curvature is by looking across the plane. So if you looked across the plane to the people on the other side of the plane, and you saw a whole row of windows, and you looked at the horizon through those windows, through a span of windows, you could see the curvature of the Earth. And that makes a lot more sense.
Well, you and I are never going to have that personal experience.
Oh, right. Because Concorde doesn't exist.
We have to show that as hearsay.
Yeah. But so, I mean, I look at the high altitude balloon footage and the high altitude rocket footage, and I've never seen any of this footage that has not shown curvature. And then people would argue, oh, well, it's the GoPro. Well, even if you counter the GoPro effect, you still see curvature of the horizon.
I think the only way that you and I could get that conclusive is to go up in a balloon ourselves, and we'll discuss what we observe.
Yeah.
and be honest as well.
While trying not to die.
Charles, I really appreciate you interviewing me and answering my questions. We've reached the hour.
Yep.
Hopefully we can talk again.
Yes, I would love to have a round two, and maybe we'll just pick a couple topics and we'll share them via email, and then we'll talk about that, because we didn't talk about theology at all. We didn't talk about cosmology. I mean, other than the shape of the Earth. But yeah, we have got lots of topics that we can share. But the key is that there's no acrimony, there's no personalities. It's just two guys talking who happen to disagree on the shape of the Earth.
Good man.
All right. Well, thank you very much.
God bless.
All right. You take care.
Bye-bye.
All right. And thanks to everybody in the chat. Sorry I wasn't able to interface with the chat. Hope you guys have a great rest of your day. Goodbye.